Mattia INTIGNANO, PhD candidate at the University of Naples, Federico II, and I'm going to present my research activities focused on a BIM workflow for stone pavements. The presentation is structured in 3 sections. The introduction will address the concepts of BIM and digitalization of built assets, and the general methodology workflow will be shown. Then the proposed methodology will be investigated with 2 case studies, one located in Napoli and the second one in Pozzuoli. Finally, the results will be discussed and a perspective for future research direction will be given. Today, digitalization is certainly synonymous of innovation in the architecture, engineering, construction, and operation field. BIM, a methodological approach for managing the information flow relating to each phase of the life cycle of an engineering asset, is based on the exploitation of digital models that transcend the 3rd dimension, bringing with them the most varied information, shared in the cloud and easily accessible by all stakeholders involved. This approach allows for the digitalization of information flow, saving time and money, increasing efficiency of the processes, and enhancing the value of projects. This research explores the suitability of BIM and digitalization tools for stone-paved roads as a powerful means of data collection, conservation, and management. The proposed workflow is based on 3 phases. In the data collection phase, surveying operations are carried out concerning geometry by means of LiDAR technologies or photos, and other data obtained by different on-site instrumental surveys. In the second phase, data are processed from laser scanners, point clouds are obtained, but also by applying photogrammetry to the photos. Moreover, all data acquired can be processed for numerical analysis. Finally, the building information model can be generated. The methodology was tested on the first case study, dealing with a stone pavement road open to vehicular traffic, namely Via Duomo, a landmark for tradition and tourism in the city of Naples. Thus, the workflow can be summarized as follows. Starting from a photographic site survey, meshes were generated, which were then transformed into parametric 3D objects. InfraWorks was used for the topographic modeling, then Civil 3D for the road corridors, and finally Revit for processing the objects to be added to the road 3D solid. Dynamo, an extension of both Revit and Civil 3D, was used for the creation of meshes from the photographic survey and the creation of objects in Revit by means of Revit's so-called families. The mentioned software exploits the graph theory to build scripts in form of nodes and links. It is the so-called VPL, Visual Programming Language. Moreover, taking as reference the article Proposer for a Catalogue of Stone Cube Road Paving in a Urban Context by Cardone, Cerni, Colagrande and Virgili, considering the regulations in force and the structural characteristics of the materials taken into consideration, a library was structured with possible stone element paving alternatives. Subsequently, another script was created, capable of searching for an optimal solution based on the required constraints and design objectives, extract the parameters contained in the model of the selected solution, perform the appropriate checks of the stress-strain conditions. Surface data were acquired from more than 1,000 photos. First of all, the element under study must always be photographed from the same distance by describing 3 imaginary circumferences around the element. One at the street level, one at mid-height to have a 45 degrees angle, one at the top to capture the element almost orthogonally. To ensure continuity of volume, the triangular light areas generated by the frames must overlap by 70%. As for the number of frames, a minimum of 20 frames per single element will be required for the virtual reconstruction software to start, that is Autodesk Recut Photo, and homogeneous lighting conditions are required too. The acquired data were processed to produce and manually edit the meshes, obtaining objects for the road pave, the sidewalk, and the curbs. The 3D meshes were processed through Dynamo to become Revit objects that, as end result, bring all the properties of both structural and stress strain. Thus, from poor graphic solids, they have been turned into parametric entities consistent not only with initial design objectives, but also with the BIM methodology. The second case study focuses on the analysis of the paving surface of a stretch of the ancient Via Domiziana under the archway of the Arco Felice, a monumental gateway to the city of Cuma, near Pozzuoli. Today, the road is open to vehicular traffic, and although it is marked as an archaeological artifact or historical and cultural interest, very little attention is paid at preserving the pavement. Indeed, the research team went to the site for inspection and noted a partial overlapping of asphalt over paving lava slabs. The British pendulum test was performed according to the European standards to experimentally measure the surface friction. The test was carried out on 6 points, chosen along a probable trajectory of the tires of passing vehicles, 5 times per each point, and the mean is the pendulum test value, or PTV. Prior to testing, the points were cleared of fine debris and the surface slightly wetted. At the same time, similarly as in the first case study, several photographs were taken around the strip on which the grip tests were carried out in order to apply the photogrammetry technique. Data were then processed, producing both meshes and point clouds. In a following phase, the digital model of the infrastructure was produced. Thus, as it exploits Bing map data, InfraWorks was used to produce the georiented model of the road, then imported in Civil 3D. The cross-section was created using Subassembly Composer, a Civil 3D extension that allows for the creation of customized assemblies by means of a flowchart in which the constituent elements of the section, it has points, links, and surfaces, are related through the definition of logical geometric parameters. Then the solid 3D model of the road was created in Civil 3D, and properties have been added by means of the property sets. In this case, the results of the British pendulum test were entered, and at a later stage, the results of the morphological analysis performed on the point clouds too. Indeed, point cloud data were entered as input to an algorithm realized within Dynamo. Thus, a first node was used to select the CSV file containing the cloud data. Then data was extracted and subsequently organized, separating the coordinates in 3 separate lists. Finally, the calculation of the parameters was performed on the global domains of all elevations and on subdomains made of 1,000 points oriented according to increasing x's and increasing y's respectively. The calculated parameters were entered into the digital model by creating a specific script for the updating of the property sets. So, in light of what presented, some consideration can be made. The integration of detailed graphical reproduction techniques such as photogrammetry, advanced geometrical surveying technologies as LIDAR, and BIM methodology is advisable for the digital reproduction of infrastructural assets. The obtained results highlight the possibility of the development of a tool suitable for the information management through a complete digital model and the added value of the use of Dynamo that can implement process automation for better performing models. A first limitation of this research lays in the computer tools used, which are designed for new continuous paving roads. Thus, the BIM models produced are mostly conceptual, since the research team had to adapt to the capabilities of the currently available commercial software. Still, the models are useful as database, shareable and updatable. Based on the above, future research should consolidate and extend workflows that implement process automation within models. Furthermore, it will be crucial to develop software dedicated to the application of BIM methodology to stone element paved roads, as well as to extend BIM standards regarding the structure of data contained in models. Finally, other data collection techniques should be investigated to extend the quality and quantity of collected data. Thank you for your attention. I'm available for questions and further curiosities.